Hi, in this video we'll see how we modify an existing connector to add new functionality, like a new action, which is what we are going to do today. So we can start with a connector like this one. It's called text utility, which has the ability to compare sentences and identify which ones are the closest to each other. And we'll take this connector and add new functionality to be able to do text or image to text, basically OCR. Right, so this is the connector. It doesn't need any configuration because it's a local utility, and it has one action for now. Right. Okay, so we can edit the connector right from the web interface. And as you see, this is the connector editor. Uh, Briefly, the connector is a definition file, so info.json. We have requirements.txt, so this is where we specify the packages, the prerequisites in terms of Python packages that the connector uses. The main file in the connector is connector.py. That's what the integration backends executes whenever we use a playbook which runs a connector action. And constant and operations are basically up to the user. This is where what has been used by the previous developer of this connector to define the different actions. Well, in this case, just one action, and constant is just a bunch of constants used in the code. Right, so we have the playbook folder where we store the playbook JSON of the sample playbooks for each connector, and images is where we store the icons. So basically, the small, medium, and the large icons that the connector has. So whenever we load the connector on the UI, these icons will be displayed. Right, we can start with the info JSON, where we have the definition of pretty much everything. So we have a section for the configuration, but we don't have it today because this is a local utility. And then we have a key here, which is a list holding all the different operations that we have or the connector supports. If you want more details about the structure of a connector, I've made a video some time ago. It's available on YouTube and on the intranet, where it goes into a bit more details into each component of a connector. Right. So what we want to do is to create a new action to perform an OCR for an image. So instead of creating it from scratch, it would be faster to simply copy the previous one and modifying what we have to modify. Right. So the name here, we'll call it image. Right. So image to text. The operation key represents the internal, the API name of this action. So we use the same thing for the annotation. This is what the users would see. So basically, it's the displayed name from the user interface perspective. So let's give it a nice name, something like image to text OCR, so that users would understand exactly what this action does whenever they open the connector. And then a bit of explication, just to detail what we are trying to do with this action. So here, this action extract, it helps to extract a text from an image file. And we can maybe write OCR between, yeah. So OCR, to be clear of what this is, the category is correct. So it's the same as the previous one. It's enabled. And then in terms of parameters, the only thing we need here is the file IRI. So the ID of the file, the file, well, basically the image, the picture we want to scan and we want to analyze. So title would be, so we can call it image IRI. So title is the name that the user see on the user interface, and name would be the internal name. So basically the name, the way we use it in the code, the API name. So similarly, we have to give a bit of details on what is this. So this is the IRI of the image file to perform OCR on, right? So the image file in FortiSOAR. It's always a good idea to give a description which will be parsed by the documentation backend, and also a tooltip that will pop up in the interface, so users will understand what is this about. The type is text, so it's an IRI, it's text. It's visible, it's editable, of course, and it's required because we cannot naturally perform the action without the IRI, without the file. The output schema is what defines the data structure of the returned data from this action. In this specific case, we don't necessarily need that because this action will only return a string, which is what has been parsed from the image. So we don't need any, it doesn't have any specific structure that we need to define here. This being said, it's very important to remember that since 7.2, I think, or 3, now we can load the previous executions of actions in the Playbook editor itself. So it's not really mandatory to use this output schema because we have it dynamically anyway within the Playbook editor. All right, so let's save this. And by now we should be able to see the second action right here. We can have a look at the other files. So just to be familiar with what the existing connector is. So if you go to connector, which is the main file of the connector, we can see that we have one function here, so get available operations. And we can see here simply fetching all the functions from the operations file. So basically this file. So we're just reading all the functions and returning, so based on this parameter, we're returning the function address of the one we're looking for, the one we want to execute. The typical class here and the two methods, execute and check health, are standard across all the integration framework. This is what actually the integration framework will execute whenever we call the connector. Right, so we don't really need to care much about this, and we don't even need to care about referencing this new function or the new action we will write, because we have this the get available operations function, which will do that for us. So it will whatever the name we'll use, as long as it's the same that we have used here, right? As long as it's the same as this one, it will reference it properly and execute the appropriate function. Right, so now we need to go to the operations, where we need to start writing the new code to implement the OCR function we spoke about earlier. So this will be the implementation of the first action, or the initial action that was written with alongside the connector. And now we need to add a new one and put it right here. So def, and then what was the name? Right, so this is very important. So we have to keep the same name so this function works. Right, so image to text, and then we will need naturally to use config and params as parameters. That's the standard. This is the standard practice in the FortiSOAR connector. So we provide the config of the connector, basically all whatever was used in the configuration. Well, if it's a network, for example, well, this is not the case here. We don't have any configuration. But if it's, for example, a network service, we'd have the server, the credentials, maybe some SSL, TLS parameters, etc. So these parameters have to be exactly the same across all the functions we use to implement actions, because as you can see here, it's called, all the actions are called providing the config and the params dictionaries. Right, let's go back here. And right, so here we need to start. The first thing to do is to read the file IRI or the image IRI from the user from the playbook basically. So let's create a variable, call it image IRI, and this image IRI will be just the params, just reading the image IRI parameter that we have defined in the info, if you remember, just a few minutes ago. So this variable will hold the image IRI. And next we need to download the file, because remember the file, the IRI is just the ID of the file. We need the actual file. We need to download it from FortiSOAR towards the file system so the connector code can use it. The connector could be on the FortiSOAR instance, but it could be as well on an agent somewhere on a different environment altogether. So to do that, we have one of the utilities, one of the FortiSOAR utilities is called download file from SIOPS, and it's available as part of the built-ins. So we just need to import it here, and we'll be able to use this function to do just that. Right, so we get the file. Let's call let's store the output of this function in this variable. We just need to provide the image IRI as a parameter, and this function will return the name of the file stored in the TMP folder by default. So to have the full path of this downloaded file, we just need to concatenate or prepend the TMP folder path to this file name. We can do that simply by, for example, creating new variables, call it file path, and we can use the wonderful Python formatting to do just that. So we'll have the first variable and then the second variable. All right, and the first one will be static in our case. Well, actually, we don't even need to do that. This would be a better option. So TMP, and then we'll just provide the file name and the file name. So this is this function returns a dictionary, and the file name is stored in a key called SIOPS file path. So SIOPS file path, right? So this should provide, SIOPS file path should provide the name of the downloaded file. We can stop here. Just make sure that we got the file, we have the path to the file, and then we can carry on from there. So basically, we just return the file path at this moment, and then we can carry on with the rest of the action implementation. So to start testing and debugging, we first need to create a configuration. So let's create one, let's call it C1. So again, we don't have to provide any configuration here. And right, so let's wait for the health check. So whenever we configure the connector, this function will be executed. And as you can see here, this function is simply an import of one of the packages, one of the libraries we use, at least the first action uses. And if there is any issue, obviously, it will return an error. Right, so we have a configuration called C1, so that's good. And now we can also test the second action. Well, it doesn't do much except downloading the IRI, but we need an IRI for that. So just need a second to get an actual IRI from FortiSOAR, and we can get one from the attachment module, for example. So let's close this one. Oh, before you close the editor, it's very important that you save your work so that you don't lose the progression that you had so far. All right, so it's saved. That's good. Let's close this one, and then we go to the attachments in resources, attachments, and then we need to use, yeah, so we have a couple of images here. So we need to use the dev tool, the developer, browser developer tool to get the required ID. So we can, for example, open this record. This is our attachment, and the file IRI, which is an attribute of the attachment, would be just here. Let's copy this, go back to our connector. Obviously, you'll find it in the create section because it's a connector under edition. We're still writing the code. Operations, and right, so we can run the action from here, providing the file IRI we just copied. So normally we should get a path because that's all we do so far. Excellent. So we have a path of the file which was downloaded from SIOPS, from FortiSOAR. Great. Now we need to make sure that the tesseract binary exists in the file system where the connector is running, because this is the library we're using is the PyTesseract to do the OCR job, and this one relies on that binary to work. So it's a wrapper basically on around that binary. So we have to make sure that the binary exists before we try or we attempt to get text from the picture. So let's remove this part. We don't need it anymore. And I'll close this. So what we do, so we can use, no, first of all, let's create a constant where we can store the tesseract binary path, right? So well, typically it's in bin, right? So bin tesseract, and well, that's already. Let's save this file. So it's tesseract bin as a static to hold the path. Just want to double check it. Yeah, okay. Right. So what we should do is to import the OS package, because OS provides this method to this function to check whether a file exists on the file system or not. So we can use something like if not os.path.isFile, and then we provide the path we just declared, which is tesseract binary. So basically what we're saying is if the file doesn't exist on the file system, we better raise an error and stop the execution, because it doesn't make any sense to carry on if this important component is not there. And then we can just raise an error to the user and stop the playbook execution. Right. So instead of generic error, we would write something meaningful, right? So people would understand why the playbook has stopped. So we can say tesseract binary missing. Please please yum install tesseract. All right. It's always important to give meaningful error messages so that people would know what to do if they face issues. Right, so we're just checking the path and raising error if the file does not exist. Right, what do we do next? At this point, we should simply start using the PyTesseract library and yeah, parse the file and return the results to the user to the playbook. So we can first we need to define the PyTesseract. So we need to define the path where the binary is, so that the wrapper, the PyTesseract, can use it. So we have a property here called tesseract command, right? And we will define it with the path we have declared earlier in the constants. So it's a tesseract binary. And the second statement should be something like, yeah. So this is where we call the actual function to do the extraction. So OCR text will store the result in a variable, and then py tesseract image, as simple as that. So image to string, and then of course we provide image to string doesn't take the path as a parameter. It rather takes an image in a pillow format. So pillow is another package, another Python package, powerful image processing. So what it does, pillow will first pre-process the image, and then tesseract will parse it or scan it and extract text from it. So first we need to convert the image into, or to open the image with pillow, and then we can provide it as a parameter to image to string. But to do that, we need to first import pillow. So from pillow import image, okay, and right, and then we can here use simply image dot open. Then we can provide our path here, the path of the downloaded file. Right. Yeah, so we cannot afford to have the TMP folder littered with all these pictures. So we have to remove it right before or right after we have extracted the image, right? Or the extracted the text. So we have OS here. Yeah. So we can use the OS remove, right, to just get rid of the downloaded file from the file system. And finally, we can return the text, the extracted text, OCR text to the user, so that that it can be used to extract indicators or any other automation purpose. Right. Let's have a quick look here. Yeah. So PyTesseract, we've used PyTesseract, but we haven't imported it. So obviously that wouldn't work. So import PyTesseract. Obviously we have to import the package before we can use it. And yeah, let's give it a try. We need to save, and let's test it with the image IRI we got earlier. See if we have any errors. Well, that's pretty much all. So here's our text. We have returned it here to the user, and yeah, that should be all. Of course, the code can be optimized, maybe with more error controls, but that's probably a topic for another day. Right. So we need to publish the connector before it can be used in a playbook. Let's give it a few seconds. Right. So here the connector should be the version we have just worked on now. So text, what was it? Text utility. Right, so we have these two functions now. Excellent. The next step is to create a playbook to sample playbook to demonstrate what the action does. So we can simply clone this one, and we will modify it to uh, to be a sample for the second action. So second action is image to text OCR, and the trigger would be on the attachment module or the indicator module as well. We will need a record, so basically a picture or an image to operate on. And so same thing here. This is image to text, and here we'll be just providing the IRI of the files, either or. So either the file IRI from the well, it doesn't matter really, because record will be whatever the record is. So this will be valid for both. So as you can see here, it doesn't matter whether we take the attachment module or the indicators. The path to the IRI, the file IRI attribute, is always the same, because we're referencing the module by their position in the list, which is, well, 0 is the first one. Right, so that's pretty much all, actually. Yeah, we can just test it now. It's in debug, that's good. Let's pick a good picture from the list, from the attachments, because we have a couple of them. Let's see how it goes. All right, and here we go. So now, for example, get the to get the artifacts, we can simply use a set variable with get artifact or extract artifacts, right? So we can say here artifacts are basically what are the artifacts? Okay, let's just save. So the artifacts is basically the output. We can see what the actual data was, and it was simply, yeah, so it was simply stored under data. So if we just add the filter, extract artifacts, we should be able to get the artifacts from that chain of characters. So attachment, this one. Right, here we go. So we have one email, which is basically what we were looking for all along. All right, so we will save this Playbook collection to use it to integrate it with the Playbook that we have just updated. So other users, whenever they use this version, they will be able to enjoy these couple of samples. Right, so we need first to save it. Let's just export it as is, and then we'll change its name later. So we export the connector, and we should be ready to merge the connector with the new sample playbooks. So export. All right. So here we have the playbook, the connector exported, and this is the playbooks. We simply need to rename the file as playbooks. Right, take the file and we put it in the right folder. Replace, and at this point we are done upgrading or updating the integration of the connector. So now we simply need to compress this folder in a TGZ format, and well, hopefully if you guys update any connector or create new one, it would be nice to submit the code as a PR to our dev team via our GitHub account. So it's github.com//fortinet-FortiSOAR. And by this, we get to the end of this video. Thanks for watching.